Intelligent Life in the Universe, co-authored by Soviet astronomer Iosif Shklovskii and American astronomer Carl Sagan, is a groundbreaking work that explores the possibility and implications of extraterrestrial intelligence. Published in 1966, the book synthesizes ideas from astronomy, biology, chemistry, and other scientific disciplines to examine the likelihood of life and intelligence beyond Earth. In this explainer, we will delve into the key concepts, arguments, and examples presented in the book. Part 1. The Universe. A Cosmic Perspective. Shklovskii and Sagan begin by establishing the vast scale of the universe in both space and time. They emphasize that our Sun is just one of hundreds of billions of stars in the Milky Way galaxy, which itself is one of billions of galaxies in the observable universe. The universe has existed for around 14 billion years, with our solar system and Earth forming only about 4.5 billion years ago. On this cosmic scale, the authors argue, it seems unlikely that Earth is the only planet where life has arisen. The book explores the process of stellar and planetary formation. Stars form from collapsing clouds of gas and dust. As a star is born, the leftover material can form a protoplanetary disk around it. Within this disk, small dust grains collide and stick together, gradually building up into planets over millions of years. Rocky planets like Earth form closer to the star, while gas giants like Jupiter form further out. For life to arise on a planet, Sagan and Shklovskii argue that certain conditions must be met. The planet must be the right size to retain an atmosphere and have a suitable surface gravity. It must orbit within the habitable zone of its star, not so close that water evaporates, not so far that it freezes. It needs to have the right chemical ingredients, including carbon, hydrogen, nitrogen, oxygen, and trace elements. With hundreds of billions of planets likely in our galaxy, the odds suggest that some will have these conditions. Part 2. The Origin and Evolution of Life on Earth. The authors then explore the story of life on our own planet as a potential model for how life may arise elsewhere. Earth formed from the same protoplanetary disk as the other planets. Its early atmosphere was very different from today's, likely consisting of hydrogen, helium, methane, ammonia, and water vapor. As the planet cooled, water vapor condensed into oceans. In this primordial soup, simple organic molecules could have formed through reactions energized by lightning or ultraviolet light. Over time, these molecules could have combined into more complex structures like amino acids and nucleotides, the building blocks of proteins and DNA. Eventually, the first self-replicating molecules arose, launching the evolutionary process. From these humble origins, life diversified into a myriad of forms, conquering nearly every environment on Earth. Prokaryotic cells without nuclei, like bacteria, dominated for billions of years. Around 1.5 billion years ago, the first eukaryotic cells with nuclei emerged, likely through symbiosis between prokaryotes. Multicellular life arose around 600 million years ago, setting the stage for the Cambrian explosion and the rise of animals. Throughout this history, mass extinctions have repeatedly wiped out a majority of species, only to see new forms radiate out and fill the vacant ecological niches. The rise of photosynthesis in cyanobacteria and later plants slowly oxidized the atmosphere. This great oxygenation event enabled the evolution of more complex multicellular life, but may have been catastrophic for earlier anaerobic organisms. The authors argue that this story, unfolding over billions of years, demonstrates life's resilience and adaptability. If life emerged relatively quickly on Earth, once conditions allowed, this suggests it may not be rare in the universe. At the same time, the many contingencies and bottlenecks in life's history, from the origin of eukaryotes to the survival of extinctions, suggest that the evolution of complex, intelligent life may not be inevitable. Part 3. The Search for Life in the Solar System. Shifting focus to our own cosmic backyard, Shklovskii and Sagan consider the prospects for life elsewhere in the solar system. They begin with Mars, long imagined as a potentially habitable world. The authors discuss early observations of Mars that suggested it had polar caps, seasonal changes, and even canals that some took as evidence of intelligent life. While these fanciful notions have been discredited, the authors argue that Mars remains a prime candidate for hosting or having hosted microbial life. It has a thin atmosphere, evidence of ancient water flows, and organic molecules on its surface. The seasonal changes in its dark markings might even be attributed to the growth and decay of organisms, although inorganic explanations like wind-blown dust are considered more likely. Venus, often considered Earth's sister planet due to its similar size, is a more challenging environment. Its thick, acidic atmosphere traps heat in a runaway greenhouse effect, resulting in surface temperatures hot enough to melt lead. However, the authors speculate that life might exist in the upper atmosphere, where conditions are more temperate. Floating microorganisms similar to those found high in Earth's atmosphere could potentially thrive. The outer planets, Jupiter, Saturn, Uranus, and Neptune, are gas giants without solid surfaces, making them unlikely abodes for life as we know it. However, some of their moons are intriguing. Jupiter's moon Europa and Saturn's moon Enceladus are thought to have liquid water oceans beneath their icy crusts, which could potentially harbour life. The authors also discuss Titan with its thick atmosphere and seas of liquid methane as a fascinating world where exotic life might have emerged. Closer to home, even our own moon may not be totally lifeless. While its surface is airless and bathed in harsh solar radiation, the authors discuss the possibility of organisms surviving in deep crevices or lava tubes protected from the extreme conditions above. They also consider the idea of panspermia, that life could have been transported between worlds by comets or meteorites. If life on Earth was seeded from space, its cousins may survive on the Moon or Mars. Part 4. The Quest for Extraterrestrial Intelligence. In the second half of the book, Shklovskii and Sagan tackle the question of intelligent life head-on. They argue that given the enormous number of stars and planets and the potential ubiquity of organic molecules, it seems likely that life has emerged many times in the universe. If intelligence is an evolutionary advantage, we can expect that on some of these life-bearing worlds, cognition and technology will have also developed. To estimate how common intelligent life might be, the authors turn to the Drake equation, a framework for estimating the number of communicative civilizations in the galaxy. The equation considers factors like the rate of star formation, the fraction of stars with planets, the number of those planets that are habitable, the likelihood of life emerging on a habitable world, the probability of that life becoming intelligent, the fraction of intelligent species that develop communications technology, and the average lifetime of a communicating civilization. While admitting the huge uncertainties in these numbers, the author's analysis suggests there could plausibly be thousands or even millions of technological civilizations in the Milky Way. However, given the vast distances between stars, even the nearest such civilization might be hundreds or thousands of light-years away. Direct contact would be immensely challenging with our current technology. The authors consider how we might detect these distant intelligences. The most promising method, they argue, is to search for their radio communications. Just as our own civilization has been unintentionally broadcasting its presence to the stars through TV and radar signals, a similar civilization around another star might be detectable to us. The book explores the challenges of such a search, from choosing the right frequencies to scan to distinguishing an artificial signal from natural cosmic radio noise. Shklovskii and Sagan also consider more speculative possibilities. An extremely advanced civilization might engage in astroengineering on a massive scale, rearranging the stars of a galaxy into artificial patterns or building megastructures like Dyson spheres that completely envelop a star to capture its energy. Such projects could potentially be detectable through astronomical observation. Closer to home, The authors even entertain the notion that evidence of extraterrestrial intelligence could exist in our own solar system. They discuss the provocative idea that the moons of Mars, Phobos, and Deimos could potentially be artificial satellites due to their unusual orbits. While acknowledging this is highly speculative and based on slim evidence, they use it to illustrate how an ancient alien visitation might leave subtle traces behind. Part 5. Contact and its implications. In the final part of the book, the authors ponder the profound implications of contact with an extraterrestrial intelligence. They argue it would be one of the most transformative events in human history, fundamentally altering our conception of ourselves and our place in the universe. Communication with an alien civilization, even through a slow exchange of radio signals, could provide an immense wealth of knowledge. We might learn new scientific and technological insights that could dramatically accelerate our development. We may gain a cosmic perspective on our own history, biology, and psychology. At the same time, the authors caution that contact could pose risks and challenges. An alien civilization might view us as a potential threat or competitor. There could be profound misunderstandings and miscommunications due to the vast differences in our biologies, psychologies, and cultures. The knowledge that we are not alone might be deeply disruptive to our religions, philosophies, and politics. The authors also consider the possibility that contact might never occur, either because we are alone after all, or because the gulf of time and space is too vast for civilizations to meaningfully interact. In this case, they argue, the search for extraterrestrial intelligence is still profoundly valuable. It forces us to confront our place in the universe and to ponder the origins, prevalence, and future of life and mind in the cosmos. Shklovskii and Sagan end on a note of cosmic loneliness, but also of profound possibility. They argue that if intelligence is rare or short-lived, then we have a special responsibility as its sole known representatives. Our fate may determine the fate of meaning and consciousness in a vast and ancient universe. This should motivate us to overcome our challenges and conflicts, to cherish and preserve the light of mind that has arisen on our small planet. On the other hand, if intelligence is common and long-lived, then our future may be far grander and stranger than we can imagine. We may be standing at the beginning of a journey that will carry life and mind to the stars, transforming the cosmos in ways we cannot yet conceive. In either case, the authors argue, the quest to understand our place in the universe is one of the noblest and most important endeavors of the human spirit. Key takeaways. 1. On the scale of the universe, with its billions of stars and planets, it seems likely that life and perhaps intelligence has arisen many times. The search for extraterrestrial life and intelligence is thus a scientific question of profound importance. 2. The history of life on Earth shows that life is tenacious and adaptive, but also that the path to complex, intelligent life is contingent and precarious. The evolution of intelligence may be a rare occurrence that requires a specific set of circumstances and a great deal of time. 3. While Mars and other worlds in our solar system are unlikely to host complex life, they may harbor microbial organisms. Studying these nearby environments can inform our understanding of life's origins and prevalence. 4. The search for intelligent life beyond Earth focuses largely on detecting radio communications from distant civilizations. While facing immense challenges, such a search is technologically feasible and scientifically valuable. 5. Contact with an extraterrestrial intelligence would be a transformative event in human history, with profound scientific, philosophical, and cultural implications. Even without contact, the search itself can provide a unifying, inspiring vision for humanity. 6. Ultimately, the question of life and intelligence in the universe is a mirror in which we see our own nature and destiny reflected. It invites us to ponder our cosmic origins, our purpose, and our future as a species. In confronting the depths of space and time, we are challenged to rise to our full potential as the universe's way of knowing itself. Conclusion. Intelligent Life in the Universe is a landmark work that helped launch the modern field of astrobiology and SETI, Search for Extraterrestrial Intelligence. More than half a century after its publication, its core questions and insights remain as relevant and thought-provoking as ever. Shklovskii and Sagan present a compelling scientific case for the potential ubiquity of life and the plausibility of advanced civilizations beyond Earth. They invite us to consider the cosmos not as a cold, lifeless void, but as a vast and wondrous arena where mind and matter may have co-evolved in myriad forms. At the same time, they temper this cosmic optimism with a sober assessment of the challenges involved in the emergence of life and intelligence and in the detection of alien civilizations across the gulfs of space and time. They remind us that while the universe may be teeming with potential, the specific pathway that led to us may be rare and precious. Perhaps the book's most enduring message is that the search for life and intelligence beyond Earth is not a peripheral scientific curiosity, but a central question for our species. It goes to the heart of who we are, where we came from, and where we are going. It invites us to see ourselves in a cosmic context as one manifestation of a universe that may be awakening to itself in countless ways. In this sense, Intelligent Life in the Universe is not just a scientific treatise, but a work of profound philosophical and even spiritual significance. It challenges us to expand our horizons, to embrace the wonder and mystery of the cosmos, and to take our place as conscious stewards of the precious flame of intelligence in a vast and ancient universe. As we continue to explore the frontiers of space and to listen for whispers from the stars, the vision and insights of Shklovskii and Sagan continue to inspire and guide us. Their book remains a testament to the audacity of the human spirit, to our eternal yearning to reach beyond our world and to know our place in the cosmos. It is a call to never stop questioning, never stop searching, and never stop marveling at the wonders that surround us. In the end, whether we are alone or one among many, Intelligent Life in the Universe assures us that we are part of a grand and meaningful cosmic story. It invites us to embrace our role in that story and to strive to be worthy of the precious gift of consciousness that the universe has bestowed upon us. That is the enduring legacy of this remarkable book and the challenge and promise it offers to us all as we chart our course through the uncharted territories of the future.